Okay, I did post a second assignment from chapter 5. This one covers the enthalpy of formation stuff in section 3. I'm going to post a practice on Hess's law, but it won't be something that is due. But that way, if you wanted to practice that for before the test, then you have that opportunity. So homework 19 is due on Sunday, and then I've already posted some things from chapter 6, but you don't need to worry about that until after the test. Any questions? Okay, so we've seen this slide before. This is just a reminder that the size of the energy is going to scale with the coefficients. So if I cut all of the coefficients in half, the energy is going to be cut in half as well. Similarly, if I reverse the equation, I have to change the sign of the enthalpy. Last Wednesday, we did a couple of examples of finding enthalpy from the tables of enthalpy of formation. So you'll have a question like this on your test. You will always be given these numbers. So I will have on the front cover a list of the enthalpies that you'll need. So you won't be able to memorize that or define that out of some thin air or something. But the examples I did on Wednesday, all of our coefficients were 1, and so we didn't have to do anything with them. So I wanted to do this example so we can see using the coefficients. So we just identify where the enthalpies of formation are for each of these. Notice that for the pure element oxygen, it's 0. And we're going to do products minus reactants, but each of the products and reactants has to be multiplied by its coefficient. So the energy of the methanol, which is the reactant, is going to be multiplied by 2, and the energy of the methane is going to be multiplied by 2. And so that ends up looking like this. And I know there are a lot of parentheses in there, but those parentheses are helping us keep track of the negative and positive. Okay, so if you plug it into your calculator, you need every one of those parentheses. If you do it in parts, do the stuff inside the parentheses first. So parentheses is the first thing in order of operations. So if we plug all of those in, we should get an enthalpy of reaction of positive 327.8 kilojoules. Is that going to be endothermic or exothermic? Endothermic. Anything that's positive, whether it's positive 1 or positive 1,000,000, it's endothermic. All set. Just got started on these slides. All right, so here is another example that would go in the reverse direction. I'm not going to spend a lot of time on this, but this is just showing you that if I have the enthalpy of a reaction, but I don't know what the enthalpy of formation of one of the reactants or products is, I can plug in these numbers to figure it out. So this reaction, carbon plus carbon dioxide giving carbon monoxide, has an enthalpy of reaction of 172. And so I can just have that enthalpy of formation for carbon monoxide be my unknown and solve for that. Okay. I won't do something like that on the test. I will only go for the whole enthalpy of reaction, but it's another thing that you can do. All right, so for just 1 mole, then you would end up with negative 110. And I will post this slideshow, so if you want to try this out on your own, make sure you can do it. Sure. All right, so we said that if we reverse the reaction, we change the sign. So that is also going to be necessary for the next thing we're going to do, which is Hess's law. So this is the definition of Hess's law. if a process can be written as the sum of several stepwise processes. So I have one overall reaction that is really the sum of 2 or 3 or 7 or 20 individual reactions. Then the enthalpy change of the overall is going to be the sum of the enthalpy changes of the steps. Okay. So here's an example of what this means. We have a combination of steps forming sulfur dioxide and then using that sulfur dioxide to form sulfur trioxide. That when we add them together, it's going to give us the enthalpy of formation for sulfur trioxide. It's going to have sulfur trioxide from its elements. Okay. So if we wanted to know what that enthalpy of formation was, we could just add together these two steps. So the first thing we want to do is check to make sure that when we add these two equations, we get the overall thing we're looking for, the goal equation. So when you're adding equations, you take all of the reactants and put them on one side of the arrow. So we have the sulfur and the oxygen from the first equation, the sulfur dioxide and the oxygen from the second equation. All of those, then we have an arrow, and then we have all of the products, the sulfur dioxide and the sulfur trioxide. Then we look for things that appear on both sides. Those are called intermediates. So do we have any intermediates? Okay, what's an intermediate? You're nodding. SO2. So if it appears on both sides and the coefficient is the same, just cross it out. Okay. And we also have, oh, this one doesn't have oxygen on both sides. We'll have a later example where we'll have oxygen on both sides, but they're not the same amount. So you get rid of the smaller one and then reduce the larger one by that same amount. We'll talk about that again. Okay, so if we get rid of these two and then we add these two together, then we've got the equation for the formation of sulfur trioxide. So that tells us we're meeting the goal equation. So we're just going to add together these two equations, or these two enthalpies. So where does this number come from? It is the sum of these two. Sum means adding up, right? All right, do we still need this slide? Okay. All right, so that one was easy enough because the equations were all primed to be in the right direction. But sometimes we need to change that reaction, what the equation looks like, in order to make the overall reactions add up. So let's say we're trying to find the enthalpy for this reaction. Okay, so it's going to be carbon monoxide plus nitrogen monoxide forming carbon dioxide and half a mole of nitrogen. And notice we don't have a delta H for this one. So the one that doesn't have a delta H, that's our goal equation. That's what we're trying to get to. The steps that we do know the enthalpy for are these two. However, if I add these up, I'm going to end up with carbon monoxide as a reactant, which is great, but my nitrogen monoxide is on the wrong side. And so I'm not going to be able to add these two the way they are in order to get the equation to look right. So one thing I'm going to have to do is switch the direction of that second equation. The other thing is I have two nitrogen monoxide, but I only have one in my whole reaction, so I'm going to have to change the numbers as well. Okay. So the slides are going to be kind of moving around a little bit, but basically I'm leaving the same equations up there. So don't think you have to start at the beginning of each slide copying things over again. I just had to keep shifting the things around to make things fit. Okay, so we need to turn around the second equation and we need to cut it in half, which means we are going to change the sign of the second enthalpy and cut the value in half. All right, so these were our two reactions. We said the first one was fine the way it was. We're going to leave that alone. The second one in white is the one we're going to be working with. The first thing we're going to do is we're going to turn it around. So notice that the reactants became products, the products became reactants, and we changed the sign of the enthalpy. So before you had positive 180, I know you can't see here, but you've written it down, it's positive 180. And now we have negative 180. Then we have to multiply everything by 1/2. So each of the coefficients is going to be cut in half, and the enthalpy is going to be cut in half. All right, so the two in black are the two that are in the right position to add up. So the first one in white is the way we started with it, then we switched it around, and now in black is the way we work, okay? So what we're going to do is we're going to, for these two in black, we're going to add up all of the reactants, three of them, boom, 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 put an arrow, and then add up all of the products, three of them, 1, 2, 3, okay? So when we do that, we get this equation. Okay. Do we have any intermediates? The oxygen. So we have a half an oxygen here and a half an oxygen here. So we can just drop those. So then what's left over on this side is the carbon monoxide and the nitrogen monoxide, which is what's in that white overall equation. And then our products are the carbon dioxide and the half of nitrogen, which is what the products are there. So that tells us adding those two should give us the right enthalpy. So then what we have to do is take the energies that are in black, the negative 283 and the negative 90, add those together, and that's going to give us the energy or enthalpy of the overall reaction. So I know the black was a little bit hard to see. Now this is smaller, but this is a little bit lighter, but that was adding everything together without crossing out the intermediates. This is with the intermediates crossed out, and this is adding these two things. Both of them are negative, so we end up with a fairly big negative number. Okay, so do you kind of get the idea how this works? Okay, so we're going to practice this. On your desk, there is an envelope, and the envelope should have slips of paper bundled together by paper clips. Hopefully the last class put things back together the right way. I want you to find the red paper clip. There should be two, so if there's two people at your desk, you can do both. First thing you want to do is find the one that says calculate the energy change. This is our goal reaction. Okay. We're going to kind of put this at the top so we know what we're aiming for. The other two slips of paper are the reactions that we know enthalpy for. And they have enthalpies on them. Okay. So the way the papers are designed is if you flip over the paper, so if I flip over this one, I'm going to go from a positive 92 to a negative 92, and the products and the reactants. Okay, so flipping the equation on the piece of paper is literally flipping the piece of paper. Okay, so what we need to do is check to make sure that our reactants and products are on the right side of the equation. So here we have a nitrogen and a hydrogen. This one has a hydrogen, but it doesn't have a nitrogen. This one has both. So I'm going to put this one so that the reactants, nitrogen and hydrogen, are nitrogen and hydrogen. So that matches up with my goal. Then I want to look at my N2H4. That's a product. So when I find it down here, I see for me, it's listed as a reactant. Now for you, depending on how you pull out your pieces of paper, it might already be a product. For me, it's a reactant. So I'm going to flip this over. So now everything is facing in the right direction. Do I have any intermediates? If you're not sure, let's go ahead and do the next step, and then we can check for intermediates again. Let me see where I come with this paper. Hand you this piece of paper, and then you'll know what to do. Okay, so we've done this first part. Find the red paper clip, find the calculate the energy, put that at the top. We look at both sides, and we flip things over. Now that we have things arranged the way we want them, we are going to copy those equations onto these lines. So my first line, I might put this equation, and my second line, I might put this equation. Okay, those are going to go on those two lines. I'm also going to copy down with the sign the energies. Yes. Too. So once you have those two up here, you're going to combine them down here in this space. So when you combine them, take the three reactants, put them down, then put just one arrow, and then put all of the products to the right of the arrow. So once you have the reaction written down, what you want to look at is, are there intermediates? And so I had done this with the previous class, and you can see there's a 2NH3 on the reactant side, and there's a 2NH3 on the product side. So I cross those out. Now, hydrogen appears on both sides, but on one side there's only one of them, and on the other side there's three. So I cross out the one that there's fewer of, all of those go away, and I subtract that one over here, so now I only have two hydrogens. So hopefully now when we add these two together, or when we get rid of everything that we've crossed out, that matches our overall equation. So the overall equation is written way at the top there. So I have one nitrogen and two hydrogens as reactants, one nitrogen, two hydrogens. And the product up there is the N2H4, and the only thing I haven't crossed out over here is N2H4. So that tells me that adding the reactions this way should give me the right energy. So my last step is to take these two energies and add them together. Okay, so I'm gonna give you less guidance on the next one. The next one is the white paper clip. So for this one, we've got iron forming iron oxide, basically rusting. And there are a couple of tricky things about this. First of all, you have one slip of paper that has all the irons on it. Use that first. So if I put it down this way, I've got the iron oxide as a reactant. I want to make it a product. I got to change it around. Then you're going to arrange the other two slips of paper so that you can cancel out the carbon dioxide and the carbon monoxide. The first thing, just get things on the right side of the equation. This is also one that is tricky because we have to multiply. The first one, we just added it up the way it was. These we're going to have to multiply. So work with your partner. And if you are sitting by yourself, feel free to work with somebody else. Turn around or whatever. Feel free to snag me as I come around.